Okay, there we go. Alright, this is how to build a Tesla coil out of CRT television. We'll take the television apart. Boom. Now, the high voltage transformer that we're looking for is this guy right here. This is the high voltage wire. Goes to the suction cup on the back. Be careful, this is all, I've had this TV plugged in just recently, but the materials that you're interested in are, I've made Tesla coils out of the transformer wire on this electromagnet on the back here. I've also made Tesla coils from this this magnet wire that runs around the tube to create the electrons inside the gas evacuated chamber. So basically what you're going to need is you're going to need to take all that apart. I've found that if you take a grinder and you pull out the motherboard and you just grind all the stuff off the back with a grinder, you can get all the pieces to fall out reasonably easy. I'm going to take a screwdriver, and this is what I do just to sort of ground out all the connections to make sure we have no live, no high voltage. So that we do that. This TV is not that high voltage anyway. But so you take it all apart. After you take the wire out of it, you unstrip. Basically, you unwind the wire, and inside there's your magnet wire. Same with the transformer on the back. You're going to need to, once you make sure that wear gloves if you don't want to do this. You can just wear gloves. You grab the suction cup on the back and you pop that bad boy off, okay? And then here you're left with your transformer, okay? That's your flyback. That's going to be your main power source of your transformer, as you can see right over here. So once you get your magnet wire, once you get your flyback, once you get your components you need off of there, now it's time for building. What we're going to do is to drive your flyback. This is a flyback right here. This is what I have powering my miniature Tesla coil I have right here. There's a rectifier inside these specific ones. Any of the ones you get out of a new school TV is going to be rectified. You'll be able to tell if it's not rectified. It'll look super old. So then the next step is you need to get a light like this, okay? You take the light apart and you pop out the circuit. Inside there's a little circuit. It looks very similar to this, okay? And you have your high voltage in pins, which are the black and white ones, and you have your out pins, which there's 4 out pins that go to the light bulb, and you're going to be needing just the outside too. If it looks like this, you're needing this one and this guy over here, and those create a high frequency pulse needed to generate the energy for the flyback. So what you do is you connect that up, you get your current to run your flyback, and then you hook it up just like a Tesla coil. You got your capacitors right here. Those are super easy to build. Those are just aluminum foil capacitors with a dielectric wound up. I will put 2 of them together. I have my spark gap over here. You can see that there's just a rod here. Okay, I'm going to elaborate just a little more on the flyback transformer. Once you pull this out of your CRT, you're going to need to find your primary pins for your transformer. The way to do that is, normally a lot of the transformers that you get, it's going to be usually these 2 pins right here. These first 2 pins are usually connected, but then there's usually a 3rd one that's also connected, and you can use either of these. Usually trial and error is basically the best way to test on a lot of flybacks, but what you're testing for is continuity. This line here runs in, gets wound a bunch of times around the transform, and then comes out the other line right there. So what we want to do is we want to test continuity. So we touch this guy, touch this one, we touch that one, and we hear the voltage, and we can hear that there's continuity there. And if you look, we're getting 1.8. So that's the primary. There's different ways you can set up these flybacks to get high voltage out of them. I'm just using the easiest method to date. So that's the one I'm going to show you. You set up your high voltage pins, and then to test your out, that's a whole nother. There's a rectifier in here, so when you're checking for your high voltage, you need to have a positive voltage of more than like 6, 7, or 8, like 10 volts or something, to be able to test current through this. Or you can just, once you get it working, you can just take and touch you can just take and run this back here, and you'll be able to figure out which one does that. So, okay, there you go. And that's that. This is basically a crash course, but it's super simple circuit. I mean, it's just you use your pulses from your circuit, from your light, to pulse into the primary on the flyback. That ramps up the current. It's rectified, so it's a DC current. One end goes to the capacitors. Now this is just a basic Tesla coil setup. I'll have the schematic down later. I can draw one, or it's, basically there was a couple different designs I saw online, so I'll post the one that I used. But then you got your positive cap over here, which is your end, and your negative goes to the other side of the capacitor. Those capacitors are connected in series, or these are parallel. I have them hooked up parallel, but they're hooked up like that. So basically, it's set up so that when the flyback transformer fills up the capacitors, because it's just one loop, it comes in here and comes out there, and then I have one line of this. I have one line coming from here into one side of the thing, goes around the coil, comes out the other side, goes through the spark gap, boom, and then comes back to the positive. So basically, once the capacitor's full, damn, okay. So once you get your magnet wire from the television, you wrap it on your 2-inch PVC. Put this fucker back. This shit's just getting in the way. Oh. Okay. You just wrap it on your thing. I made this. This is a homemade toroid. This is coaxial cable. The sheet you see in the background is a radiant energy receiver. I had it hooked up to an ammeter to register the amount of current that I was getting from it until I blew my ammeter. So, and this is another small version of a Tesla coil in which you did the same thing. I have my my light circuit set up here. It comes in, it powers that, goes into my, this time I'm using saltwater capacitors. The positive is on the outside, the negative is on the inside. Same thing, I have it hooked up to the negative, one side up to the positive. When it makes enough voltage inside the capacitors, it sparks across the gap, creating an electromagnetic pulse around this ring here, transferring it to the inside coil. The inside coil is hooked up to a ground, and it's hooked up to a sphere on top. This is very, very fine magnet wire here. This is like 30 or something. It's super fine. This stuff was, I don't know, I want to say 20. I don't know. I'm not very good at gauging the wires because I've just been getting it all. But okay, ready for a demonstration. So yeah, this is how the Tesla coil works. Let's see here. I'll plug this bad boy in. Show you the small one first. Okay. So you can see that's the bottom one. It's sparking the spark gap, and you can't really see very much from this one because it's so small. But if we take a light bulb here, okay, that's the small one. Unplug that one. I'm going to hook up the other one. Okay. And now we'll get a couple of bulbs over here. Ready for this one. I'm going to plug in this guy. So he's got a lot more power, and if you look closely, I'm lighting these bulbs pretty well. That coil. Only thing is the transformer only runs for a little bit of time because for some reason that light bulb circuit. Okay. Okay. So yeah, that's it.